Hi everyone, my name is Harry Timothy. I'm Android engineer from Dana, Indonesia. And this is the second time for me ever deliver this topic in droidCon, Reactive App Orchestration with StateFlow. So what do you think when you read or hear the word reactive? Does it remind you to a specific architecture or a specific design pattern, like observer pattern or state pattern, or a specific library like Rx Observables or Jetpack's LiveData? Whatever it is, today we're going to focus on Coroutine solution. We're going to see how far Coroutines has evolved. But speaking about evolution means we have to understand which came first and then what's next. So as we are going to learn about StateFlow, let's have a quick review of what exists before StateFlow. As we know, coroutines firstly came with coroutine scope and dispatchers. And then we have two types of channels, buffered and non-buffered channel. Talking about nostalgic moment, maybe it was when we were still learning how to work with suspend function, how to launch it, how to handle exceptions. Even if you're still new to coroutines, there are many online sources today where you can learn from the most basic cases. And in that case, don't worry, this slide was made so you can catch up with almost everything. And then flow was introduced. It is a cold stream which allows us to asynchronously handle stream of data in the same sequence it was emitted. As we're going to talk about StateFlow, it is very important to understand this concept because flow is the base foundation of understanding StateFlow. So let's see how to work with flow. This example is very simple. There is a flow builder to emit three different values of string where the goal is to print any collected value in separate lines. Using this code, we can see the output prints those texts in exactly the same order it was emitted. This shows that flow asynchronously emit values in sequence. Or alternatively, we can use sFlow function to convert a collection or a sequence into a flow, then collect its values. It will give us exactly the same output as the flow builder. I think this code is easy enough to understand and clear enough to show you how to work with flow. Just keep in mind that you need a suspend function or a coroutine scope to collect the data. But now the question is, can we use what Coroutines has so far to provide state management? Let's consider this case. Let's say we have a feature which starts with an initial state. This is the state where the view was rendered for the first time after an activity or a fragment is started. Then let's say clicking a button triggers a loading state, which shows loading animation. And the result can be either success or error, where the success state returns a list of string and the error state returns a message. So to sum everything up, we have a total of 4 states. Again, the question is how to provide state management. If you're thinking of using Rx subject or LiveData, you're cheating because right now we're talking about coroutines. About whether or not coroutines can be the answer. So can you think of any coroutine solution that might work? Obviously, there are several ways to achieve it, but one of the most recommended solution is to use conflated broadcast channel. So firstly, let's focus on the name conflated broadcast channel. Conflated means every subscriber will only receive the most recent values. And like a broadcast channel, it broadcasts emitted values to all open subscriptions. Let's see how to manage states with this. Conflated broadcast channel has a constructor which immediately sends the initial value upon creation. This is where we can pass the initial state. And then we can either use consumage or consume as flow on its open subscription, but I prefer using consume as flow for today's topic. Then we render the collected state using when to differentiate each states. And to emit values, we can use either send or offer function, where we can put any state as the parameter. Providing state management using conflated broadcast channel can be done this way. However, bear in mind that conflated broadcast channel can be closed or canceled. It is also too complex to provide something as simple as state management. Therefore, we can conclude that conflated broadcast channel is not suitable for state management. So we need a better solution, which is exactly the reason why StateFlow exists today. StateFlow was firstly introduced in Coroutines 136 as a new primitive for state handling. Means StateFlow should be considered as the best coroutine solution for state management. It is very important to always keep in mind that StateFlow is a subclass of flow. It is a flow under the hood, a flow that represents a single read-only state. This means StateFlow also inherits flow operators, such as map, debounce, filter, zip, and so on. StateFlow has a single updatable data value that emits updates to its collectors, which sounds very similar to LiveData. And what makes it more similar is the fact that StateFlow also came in two versions. There is a mutable StateFlow and the immutable StateFlow. Let's take a look at this example. Just like how we use LiveData, we keep mutable StateFlow as a private field and only expose the immutable one. In this example, we are creating a StateFlow of string. And here we have a private observe state function, which triggers the data collection and prints every string updates. Then we have a public main function, which calls observe state, then update the StateFlow value 2 times. The output shows that StateFlow emits value updates in exactly the same order it was assigned, which is again very similar to LiveData. Another important concept is the fact that StateFlow never completes normally. We can cancel the downstream data collection by canceling the coroutine scope we use to collect data changes, but we cannot cancel the upstream data emission. And this is the reason StateFlow wins over conflated broadcast channel. As conflated broadcast channel doesn't have this upstream emission behavior, it will eventually be replaced by StateFlow in the future. So this is to conclude how StateFlow works. Very similar to LiveData. And because of this similarity, some people begin to speculate that StateFlow exists to replace LiveData in the future. Although this is a mere speculation, I personally find it very interesting to compare both StateFlow and LiveData. So let's see how they are compared to each other. When creating a mutable StateFlow, we cannot leave the constructor empty. which means we always have to set the initial value as constructor parameter. This behavior is different with live data, where it does not require initial value. This is the first and the most visible difference they have. As mutable StateFlow is designed for state management, it suggests that we cannot leave a state empty. So there is no such thing as stateless state. Another difference is that StateFlow needs either a suspend function or a coroutine scope to collect data changes, while live data does not. In live data, data changes are observed by passing it to a lifecycle owner to an observer. The next difference is the most interesting one. StateFlow replaced one most recent value to new subscribers. In this example, we assign A as the initial value of the mutable StateFlow. We start the data collection using coroutine scope.launch, then assign B and C as the next values. The output prints ABC. While in live data, the behavior depends on which method we use to observe data changes. If we use observe forever, we will get ABC as the output as well. But if we use observe, we will lose the initial value because um, observe function ensures the observer to only receive events in lifecycle owner if the lifecycle owner is in started or resume state. As the result, we only get B and C as the output. And lastly, StateFlow has many operators due to the fact that it is a subclass of flow, which means it inherits flow operators, while live data has only 3 kinds of transformations. Considering this difference, whether you want to stick with live data or you want to migrate to StateFlow, it is totally up to your decision. So far, we have learned the basics of StateFlow. We understand the difference it has with the live data. And let's say we finally decided to adopt StateFlow to our app architecture. The question is where to start? So the next thing I'm going to explain is not only how to adopt it, but this can also act as a simple migration guide. Assuming we currently use MVVM and we have a main view model class, and this class has one use case, getDroidCon events, which returns a list of string, and we have a private mutable live data with state.initial assigned as the initial value, and an exposed public state, and also a download events method, which starts with changing the current state to state.loading, then triggers the get droidCon events operator function. If we finally decide to migrate this code to StateFlow, all we need to do is to change this part to this. As we can see, it is a very simple migration process with a small amount of code changes. At this point, there are some people asking me, okay, that's MVVM, but what if we use MVP? The answer is, trust me, you might not want to use state management with the presenter, because if we keep the view state inside the presenter, or if the presenter knows the current state of the view, then what's the point of separating the presenter and the view using a contract? Actually, keeping view state inside the presenter is possible, but it makes your presenter not clean anymore. So better use view model to do state management. And I think that's it for the view models, for the view model part. But now, what about the view part? Let's say we have a main activity which consists of a private view model field. and an observe state function which observe the state changes triggered at onCreate before downloading the events. And we also have a render function to render the current view state. If we are migrating to StateFlow, all we need to do is to change this part to this. We use lifecycle scope because firstly we need a coroutine scope to use collect function, and we also want the data collection to stop when the lifecycle owner is destroyed. Otherwise, the collectors will stay active and this might not be the behavior we desire. I think this concludes the migration guide. The next question is how to test StateFlow implementation. Testing StateFlow implementation involves a very simple process, as the implementation itself requires a coroutine scope. Then obviously we want to use a test coroutine scope to do unit testing. Let's say the goal of this test is to have the download events function to emit values equal to the expected values. The first step is to define the expected values. This is where we define which state we expect to be emitted when we call download event function. Then we create an empty mutable list of state where we can add every emitted values inside. The goal is to keep track of the state changes, so viewModel.state.collect will add every state changes inside the mutable list of state. And then we simply call download events to trigger the data collection. Then finally, we assert that the emitted values is equal to the expected values. This is how we test StateFlow implementation. And I think this also concludes my explanation of today's topic. If you have any question, feel free to reach out to me. You can contact me through email or LinkedIn. I can give you the slide and code sample if it is required. So, any question? Okay, here we already get the first question. Is StateFlow lifecycle aware component? LiveData is big plus if StateFlow doesn't do that. Okay, it's a very good question. So StateFlow is not a lifecycle aware component, as it never stopped normally. So the data collection, yeah, we're the one who have to stop the data collection, and to do that, we might want to manually cancel the coroutine scope, or just simply use something like lifecycle scope, so that let's say when the activity or the fragment is destroyed, the StateFlow data collection is canceled as well. So obviously, LiveData is a lifecycle aware component, but we can also combine it with StateFlow, so something like using a lifecycle scope to ensure that everything works well. The next question is, what if user rotates device? Would StateFlow case the result and would emit the last result? I guess it would. Want you to confirm. Okay, really interesting question. Um, if we rotate the device, then uh, the data collection still continues, but maybe we'll just get the latest result, the latest emission, and not casing all the result that it has emitted so far, because that's how it works. So that's the answer of this question. And the next question is, what are the things which conflated broadcast channel can't do compared with StateFlow? Okay, actually, StateFlow exists to eventually replace conflated broadcast channel in the future. That even conflated broadcast channel has deprecated some function. For example, the for each collection. Yeah, there's a something like for each collection that it had before, and they deprecated. Um, and even if you read the documentation of StateFlow, you can find several times mentioned that it is there to eventually replace the conflated broadcast channel. So I think everything that conflated broadcast channel can do, StateFlow can do as well. And not just that, but StateFlow can do even better. So that's for the answer. Next question. Can StateFlow object be used for data binding inside layout XMLs? Um, Actually, this is a very interesting idea. To be honest, I've never tried it before, but I think it will work because basically data binding means that all we need to do is to bind the object with the XML layout. And as long as we can bind the object, then it will work. It will work. Okay, thanks for the question. And the next, is state and sealed class. Okay, state, um, it can be a sealed class, it can be enum, it can be anything, but it's the best to use sealed class for state because you want a state to be immutable. We need state to be immutable. And that's why we need to make it as a sealed class. Next question, can StateFlow be used to notify other fragment intent service activity like using date event bus? If it can, is it a good approach? Okay, this is very good question because actually recently, not recently actually, I believe it's 1 or 2 months before that they changed the structure of the state flow. So firstly, state flow extends flow, but now it's not like that. It extends shared flow, and shared flow um, is something that is designed to create something like event bus. So this shared flow extends flow, and then state flow extends shared flow. So can we use it to make something like event bus? Of course, we can do it. If it can, is it a good approach? Yes, it is a very good approach, but maybe we will prefer using shared flow instead of state flow for that. Thank you for the question. And next, have you used StateFlow with Compose? How does it work with composables? Again, this is a very good question, and someone asked me this question before, and um, yeah, the answer is yes, we can use it with Compose, and um, all we need to do is to map the view state with the object we need to render. And yeah, that's we call the view state management. And that's the very reason why we use StateFlow. Okay, thanks for the question. Any other question? Is there any other question? Okay, I think um, I don't see any other questions. So thank you for attending this this session. And if you have any question, you can just contact me through email or LinkedIn or through speaker. Oh, we still have another. We have another coming. Um, does it work for switching from functions returning live data to functions returning state flow? Um, yeah, I think it's worth it. It's worth it because again, sometimes our feature keep evolving. Keep evolving means that someday something that we make as a simple feature, it can be complicated, it can become complex one day. And again, when everything gets complicated, we might want to have a lot of operators available to help us. For example, we might eventually want to use zip. Okay, can we use zip with live data? I don't think so. So yes, it's worth it to migrate live data to StateFlow. Thank you for the question and a great informative talk. Thanks for your info. Okay, thank you very much. Okay, I'll share the link for the PPT later at the speaker blog. And okay, I think that's it for today. Thank you very much for attending this session.